Okay, can you see the screen, the geometer sketchpad? Can you hear me?
Can, teacher.
Can hear, can see the screen? The
Yes.
geometer sketchpad can?
Yes, can.
Okay, can, thank you. Right, so coming back to the second problem, the second problem is you have to change it to this form first. So the index is at the top. This one, the index at the bottom cannot differentiate. So you bring the index to the top. In the process of bringing the index to the top, the number 2 at the bottom will not follow. The number 2 cannot follow to the top. Only the function x follow to the top. Then the 2 remain at the bottom. Okay, so finally we have 15 negative 15 over 2 x to the power of negative 6. So if you want to bring back the negative 6 to the bottom, you can do it like this. It looks nicer. You don't want to bring back, you leave it like that also can, right? But if the question says simplify, then you give it in this form. Simplify, you remember the word simplify? Simplify, simplify, something like that, right? Okay, so another function. This time I call it y. So once I call it y, the derived function will be dy dx. Okay, now this again is in disguise. Disguise means menyamar. So you cannot differentiate it straight away. You cannot recognize what is the function. So how to differentiate this thing? Again, this thing, you have to make use of your knowledge of indices. You convert it into index form, not in the square root form, but in the index form. So this square root without a number in front is a square root. With numbers in front, then they may be the cube root, fourth root, fifth root, and so on, right? So no number in front, this is actually square root. So square root will be half to the power half. So 3 and the square root is half. So the y is actually 3 over 2. 3 over 2. So from a square root form, I change to index form. So in the index form, I can differentiate. Bring down the number, this number, bring down to the front. Then the index less by 1. So it becomes 3 over 2 x to the power of half. 3 over 2 minus 1 is half. So it's half. Right? So you can leave it in this form, or you don't want to leave it in this form. So if they say simplify, make it look nicer and so on. So how are you going to do? Yes, you're going to do like this. So it will be 3 over 2, 3 over 2, then square root of x. Square root of x, something like this, right? So you change back to the square root form. Just like earlier here, index form, you change to this one. Here, index form, you change to square root form. Um, so, so what we can see here is, I summarize what we can see here. Now, what we can see here is that the index of the given function that they ask you to differentiate, this index 3 can be a positive integer. Sometimes the function is given to you in this form, where the x is at the bottom. If the x is at the bottom, then the index is in negative integer. The index is a negative integer, right? Now sometimes not wrong, not wrong, unless they say simplify. Now sometimes they will give you in this form, square root form, right? So in this form, it will be a fraction. The index will be a fraction. So now Sherwin asks if this half I don't want to change back to this form, can or cannot. Now, if they didn't say anything, then you can leave it in this form. But if they say simplify, you need to leave it in this form. You need to leave it in this form, right? If they say simplify. Or maybe uh, the question consists of many parts. So probably if you want to continue to differentiate, you leave it in this form, it will be better. If you want to continue to differentiate, you leave it in this form. Similarly, if you want to continue to differentiate, you have to leave it in this form. If you continue to differentiate, it is no longer called the first derivative. It is called the second derivative. Later on, I'm going to show you lah.
Teacher,
Yes.
teacher, for the example 3, it doesn't have the value for A, is it?
Wait,
For
A is
example,
1. A is 1.
A, 1.
If you don't have
Okay,
anything, that means the A is 1. If there is a number
okay.
there, then you copy down the number. You copy down the number. So what I'm showing you in
Okay.
these examples, 1, 2, 3, they are, the index can be a positive number, the index can be a negative number, the index can be a positive or negative fraction. Positive or negative fraction. Sometimes it can be negative fraction. If the square root is at the bottom, then it's a negative fraction. And from these three examples, I also show you the function that they give you, that is given to you, can be like this. No, no y or x in front, y or f in front. So you have to do like that, d dx, meaning you are differentiating with respect to x. If it is given to you in fx, then after differentiating, you will be called f prime x. And if it's given to you in y, after differentiating, it will be called dy over dx. So you already used to the different way of telling you the function.
Yes.
Are you used to the different type of function, different way of calling the function? Pikat dulu. Okay, so if you have thought about it and you can see the different categories there, then we move on to something special. So can we move on to something special?
Yes, can,
Yes,
sir.
okay. Now, the function given to you is y equals to 5x. We're going to differentiate this. Wow. Let's see what we are going to get, right? So if you're going to get this one, the number in front, you just copy down. Then the index, there's no index there. It means the index is 1. Okay. So 1 minus 1 is 0. 5 to the power of 0 is not 0. 5 to the power of 0 is 1. 1 times 5, 5. So dy dx is 5. Okay. So I'm going to tell you, in general, if there is a number, then x, when you differentiate, the x will disappear, and you are going to get the number left. This is very important, right? Or otherwise, x no index there, how to differentiate? Then you ask, then you panic. So you just remember it that way. If the function consists of x only, there is no x to the power 2, no x to the power 3. When you differentiate it, it becomes that number only. So now I ask you one question. Y equals to x. Differentiate, what you get? Y equals to x. What's the
Wait,
answer?
teacher.
Y equals to x only, nothing else. No power, no number in front. What is your answer? What is dy dx?
1, teacher.
Correct, 1. Because the number in front of x is actually 1. So when you differentiate x, you get 1. You differentiate negative 10x, what you get?
Pardon, teacher?
If you differentiate negative 10x, y equals to negative 10 then x, what is your answer?
Negative 10.
Correct, negative 10. If you differentiate fx equals to 2.31 2.31x, what do you think is the answer after you differentiate this? Fx
2.31.
2.31, correct. Let's say if your function is uh, 3x over negative 2, you differentiate this, what you're going to get?
Wait, teacher.
The x is power of 1 only. So when you differentiate x with respect to x, what you get?
Negative 3 over 2.
Correct. Correct. Negative 3 over 2. So you know this, the special case. So I will mention to you this one, y equals to kx, dy dx is the k. You're always left with the number only. Okay. Now the next one is if your function is no x1, just a number only. When you differentiate a number, what you get? 0. When there is x, the x will reduce by 1. When there's no x, you reduce some more, you will get 0. You will get 0. So if you differentiate a number, a constant, you will get 0. Okay? So this is what you get, right? If y is a number, then you differentiate, the dy dx will be 0. Is that okay?
Okay.
Okay. So now you try to do this and see. This one. I give you some 5 minutes to do this. And you tell me your answer. This one you just differentiate one by one. One by one. I give you 5 minutes to do it. After you tell me the answer. Okay, can or not? Can, then I'm going to show you the answer on the next page.
Okay.
Okay, I'm going to show you the answer on the next page. Now, before I show answer, what is this A answer for A?
Negative 97,
Correct. What is the answer for B?
25.4.
No,
No,
no. What is the answer for B again?
0.
0, correct, because there's no X, there's 0. If X, then you'll be the number. Okay, right. So, yes, negative 97, 0. Then this one. Do you know how to change?
Teacher, is it 5?
Uh, no, answer not 5. Because the square root there, there will be X. There will be X. Because there's a square root there. Okay, let me show you. Okay. Now, this 2 over square root of x to the power of 5. 2 is a number. You don't differentiate, you put outside, right? Then x square root of x to the power 5 is x to the power of 5 over 2. This is from the lesson on indices in form 3. How to change it to index form, right? So square root is half, then power 5, power 5. Now this whole thing is at the denominator. So you want to move it up, you have to put a negative sign there. Now so far, what I have been doing here is not differentiation. I just change it from square root form to index form. So no differentiation. This function here is still known as y. Is still known as y. It's not called dy dx. Okay, so now already in index form, I can differentiate. So when I differentiate this, I bring the 2, I leave it outside. Negative 5 over 2, I put it outside. Negative 5 over 2, right? Then the original index negative 5 over 2, I minus 1. Minus 1, right? Okay, so simplify. The 2 and 2 will cancel and it will become negative 5. Then, got some more. Li Ying got negative x to the power negative 7 over 2. This one minus 2 is negative 7 over 2. So if you want to move it down, the negative 5 is at the top. Oh, move down, then no more negative. Sorry. Sometime type also type wrongly. Okay, move down, no more negative, right? No more negative. Then this thing change to square root form, square root x to the power of 7. Okay, so is this okay or not? Can follow how to differentiate?
Can.
Can. Okay, then we continue with the last one, this one. Now if you have several terms one by one like that, how are you going to differentiate this? I'm going to show you. Okay, now if your fx is 3x squared minus 5x plus 7. So when you ask to differentiate with respect to x, you differentiate one by one. This term, differentiate. After that, differentiate this term. After that, you differentiate this term, right? So you differentiate one by one. So the 3x squared. What did I tell you just now? Simple one like this, you have to do mentally already. You cannot do mentally, then afterwards more and more difficult, right? So this one, I just think like that. Or 3x squared. 3, then the 2 bring in front. Then the 2 less by 1. So 3 and 2 become 6. X less by 1 become x. Okay, so it's 6x. Okay. The next one, negative 5x become negative 5. This one you have to respond immediately. Differentiate 7, 0. So this is your answer, 6x minus 5. Okay,
Teacher,
so yes,
7 become 0, is it because behind the 7 doesn't have x, so it's 0?
correct. If it is a number, don't have x, it will become 0, correct. Okay. But I want to show you in this example is that you differentiate one by one, one by one like that. Okay, now must have tried just now lah. If not, then you wouldn't appreciate it when I just show you like that. You wouldn't appreciate that. I just give you some time to try. Now, most of the time, it will not be very simple, direct like this. Sometimes you will see more complicated function. So you look at more examples. Now this example involve multiplication, where you need to expand, division, where you need to cancel away the common factors. Okay, let's say take first question. Example number 1, y equals to 2x bracket x minus 3. Now this is multiplication, not like this one, subtraction and addition. So you subtraction and addition, you can differentiate one by one. Here, because of the multiplication, the bracket there, you cannot differentiate one by one. If you differentiate one by one, everything will be wrong. So what to do? I have to expand. I multiply out 2x multiplied by x, 2x squared. 2x multiplied with negative 3, negative 6x. So I expand. Once I expand, I see that they are one by one like that. Now can differentiate or not? Can. Just differentiate. The 2, leave it there, then bring down the 2, become 4. Then the 2 less by 1 become 1, so become 4x. Then the 6x differentiate become 6. Okay, so answer dy dx is 4x minus 6. Again, please take note that at this stage here, y equal to 2x squared minus 6x, I have not differentiated the function yet. So this function here is still known as y. It's not dy dx. Now, once you have differentiated this function and it becomes something like this, you can no longer call this thing y. You must call this thing dy over dx. This is very important because I mark the exercise book. I see they just mix up everything. Y that time they call dy dx. Dy dx, some call it y. Cannot. Then finally they do everything, they just write down the answer. This is the answer. Dy dx is this. Now, the working above all the y and dy dx they mix up. Final answer, they give you the correct answer. That is not the proper way to present the answer. In fact, it is wrong. If you mix up the y and dy dx, it's wrong. Okay, so bear in mind, if you are only simplifying the function, don't put dy dx, don't put f prime x. Once you have differentiated, call it dy dx or f prime x. Don't call it y anymore. Okay, very important. Okay, right, the next one. Second example, fx is equal to 2 bracket 2x plus 1 holding square. Now again, you encounter this bracket there. Now this bracket there shows that they have more than one factor. You don't differentiate them one by one like that. Without expanding, you don't differentiate one by one, right? Unless you have expanded, then you can. So can you differentiate straight away from this in this form? Cannot differentiate straight away in this form because there's a bracket there. Can you differentiate this straight away in this form? Cannot, right? So unless it become like that, one by one like that. So this function, I'm going to make it one by one like that. How to make it one by one? Expand, right? Expand. So expand become 4x squared, 4x plus 1. Right? Then you multiply the 2 inside, 8x squared, 8x plus 2. Now I ask you, hey, until this step here, have I differentiated? So many steps already, I've done so many steps. Have I differentiated? No. So what is the name of this function here? It is still known as fx. Now differentiate. Because it's one by one like this, you can differentiate. So differentiate becomes 16x. Differentiate become 8. Differentiate 2 becomes 0. Yeah, becomes 0. So this is how you're going to differentiate, right? And this is qualified to be called the derived function. We can call this f prime x, but don't call it fx. Call it fx, then it's wrong again, right? Hmm. Okay, more examples. Now, so far what I've shown you here is they involve two brackets. You have to multiply together, expand, then you get the function, which is a polynomial. This one is a polynomial. Then you differentiate one by one. Now, how about this one? Differentiate this thing with respect to x. Now, here they have no bracket, but there is a division line there. Now, once you see this line, separate them into two like this. You don't differentiate them yet. You have to simplify first. So one of the technique to differentiate this is to separate them into one by one. How to separate them into one by one? So 3x, the bottom is x, so 3x squared divided by x, 4x divided by x, 5 divided by x. Now because at the denominator there is only one term x, you can put 1 divided by x, another 1 divided by x. Perfectly alright. But if the bottom here is not x, is x plus 2, 2x minus 5 and so on, then you cannot separate them one by one like this. Okay, since it's only involving x, x squared, x cubed doesn't matter. You can separate them one by one like this. Okay, so once you've separated them, simplify first. Cancel away the x, you have 3x. Cancel away the x, you have negative 4. This one, 5x, 5 over x is 5x to the power of negative 1. So this is how we're going to simplify. And after simplifying here, 3x, 4 plus 5x to the power of negative 1, you have not differentiated it yet. So the d dx is still in front of this function. So now you differentiate 3x become 3. Differentiate negative 4 becomes 0. Differentiate, oh, you have to bring down the negative 1. Sorry. Mistake, no? Mistake, mistake here. The mistake is here. This one is negative 1. You bring down, become negative 1. Right? Negative 1. Negative 1, then the x less by 1 become negative 2. So negative 1 times 5, this is negative. Negative 5 over x squared. Negative 5 over x squared. Okay. So far, any question or not? We have 9 minutes left. Any question?
Understand, sir.
Can understand. Now, can understand is not good enough. You have to do a lot of practice. Practice. Don't be lazy. Lazy. Don't want to do. Cannot.
Bitches.
Who is lazy? Cannot be lazy. Have to do the work. Okay. So you understand, then you look at this. Then if you understand, then you have to do. Because just by looking at how I do it, you understand how I do it, but you don't know how to do it in the exam unless you do a few times. You experience it with yourself, then like I always tell the people, you don't know how to swim, then I show you here. This is the one, you swim like this, like this. Tomorrow you go and swim, you jump into the pool there, go for competition. Cannot, no, right? You have to go into the pool slowly, then do a few times, then come out, rest, then do again. Then only you can go for the competition. Cannot straight away like that, right? So you need practice. These are skills, kemahiran, cannot. Okay, so this one you understand. I'm going to show you the last one, right? Last one. Last one, something like this. There's a function at the top, there's a function at the denominator. Now this one, you cannot do that like this, separate x1, x1 like that, cannot, right? This is whole thing. X minus 1 is a whole thing. So this normally you need to factorize like what we did for our limit just now, the beginning of the lesson, for our limit, right? So you have to factorize, and sure you will be able to factorize. If not factorize, then you have to use another method. The method will be shown here, right? Here, chain rule, product rule, quotient rule. So this one I'm going to show you tomorrow and next week. Tomorrow and next week, right? So meanwhile, this type of problem here, you have to factorize so that you can cancel one of the factors away. So as you factorize, you cancel one of the factor, you are only left with 2x minus 1. 2x minus 1 is not the dy dx yet. 2x minus 1 is not the derived function yet, right? So you have to differentiate. What you have done earlier is called simplification. You just simplify the function. You have not differentiated yet. So you still call it fx. But once you have differentiated, you call it f prime x. You call it f prime x. So, okay, right. So we look at the textbook, right? Look at the textbook. So this is what I told you just now. This one, this is the chapter, right? Chapter 8, this down one, chapter 8. Where is it now? Linear programming, not here. Okay, bottom here you can see chapter 8. Right. So this is the velocity, acceleration, displacement. You're going to see this. And this chapter need to make use of what you have learned in differentiation, and also the next chapter, integration, right? So this is what I want to refer you to the homework for today. Before I dismiss you, we look at the homework for today. Still very slow, right? Okay, limit. Okay, this one we have done. Here, homework for today is this one, right? This one. Now, what you can do is only question number 1, question number 2, actually number 3 and 4 you can do. You know how to divide them. This one is you have to multiply out. This one you have to multiply out. Then this one you have to divide one by one, like the example earlier. Now, anyway, you try this one, and if you don't know, tonight you put inside the telegram. I'm going to show you. Then tomorrow afternoon, evening, I will explain, right? I show you the answer, then tomorrow evening I explain. So this one, self-exercise 2.3, right? Now, first derivative composite, this one cannot do. This one I have to teach again, right? So you do only page 41, 2.3. Page 41, 2.3. So I type here homework, page 41, 2.3, right? Homework, page 41, self-exercise 2.4 point, what point 3? 2.3. 2.3. Self exercise 2.3. 2.3. Okay. This one underline, and this one different color. This one put a different color there. Different color. Okay, right. So you look at this one, it's not easy, you know. This one not easy. So let's say for example number 3, 3A and 3C. You bear in mind 3A and 3C. I'm going to switch back. 3A and 3C. 3A and 3C. Okay, now 3A, you have to expand like this. 3A, you have to do this, like this, expand. Then 3C, is it C? You have to divide one by one like that. But the bottom one is not x, you know, square root x, square root x, square root x, all this square root x. I don't know your knowledge of indices. You need to make use of your knowledge of indices. You have to simplify until you have one term with the index there in fraction form, and you differentiate. Quite difficult, right? Quite difficult. You have to try tonight. Then cannot, I will show you immediately. Then tomorrow I will explain. Okay, so it's going to end now. This one is going to end. So you remember that this is the homework for today, right? Page 41. If you forget, then you look at the video. I'm going to send you the link, right? So you're going to stop here. Okay, so
Thank you, teacher.
thank you. That's all for this session. Tonight I want to see your question. Tonight you give me question.